All right, get ready because today we're going to be looking into some AI research that could seriously shake things up.
Oh, yeah.
Yeah, we're talking about AI that can basically hit the reset button, like taking a power nap for its digital brain.
Interesting. Like refreshing itself.
Exactly. It's all about keeping AI sharp and preventing it from, going off the rails.
I see. I see. Because we all know how important sleep is for us humans, right? Helps us consolidate what we've learned, clear out the clutter, you wake up and you're ready to go.
Yeah, exactly. And researchers are exploring whether AI might need a similar process to, well, stay on top of its game.
Fascinating.
Especially when you think about those moments when AI seems to, lose it a little bit. Like, have you ever seen a chatbot just start spitting out random words?
Oh, yeah. Or like when a self-driving car suddenly forgets the rules of the road, it can get a little unnerving.
Yeah, unnerving is a good word for it. That's actually a big problem in the AI world, and it's called catastrophic forgetting. Basically, AI models can kind of degrade over time.
Right, they forget what they've learned or get less accurate in their responses. That's not good.
Definitely not, especially when you think about the real world applications, self-driving cars, for example, or medical diagnosis AI. Reliability is paramount.
Absolutely. I mean, you can't have those systems making mistakes. The stakes are too high. So this new research, self-repairing neural networks, artificial sleep as a mechanism for long-term AI stability, might just have some answers.
And the cool thing is, they made the whole project open source, so anyone can check out the code on GitHub. Just search for Richard Aragon Artificial Sleep.
Wow, open source. That's great.
Yeah, but don't worry, we'll break down the key ideas for you right here. So tell me, how can AI possibly sleep? What does that even look like?
Well, the researchers are essentially suggesting that mimicking sleep cycles could be the key to building AI systems that are not only intelligent, but also super resilient and reliable over long periods.
So just like sleep allows our brains to, process information, recharge, they're proposing a similar process for AI.
Exactly. And it all comes down to preventing that dreaded degradation that we were talking about earlier.
Got it. Now, did they use some like massive supercomputer for this experiment?
Actually, no. They started with a smaller language model called Hugging Face TBS Small LM2 135M.
Huh.
Kind of a guinea pig for AI sleep therapy, if you will.
Okay, I like that. So how do you measure whether an AI is, sleeping effectively? What are the signs of a well-rested artificial mind?
Well, they tracked a couple of key things, right? One was perplexity. Imagine the AI is trying to write a story. If that story makes no sense and the words seem all jumbled up, that's high perplexity.
It's like the AI is confused, basically.
Yeah, and the researchers want to keep that perplexity low so the AI stays coherent.
Makes sense. Low perplexity equals a clear-thinking AI. What else did they track?
The other thing they looked at was repetition ratio, which basically measures how often the AI repeats itself.
Like when someone's super tired and they keep telling the same story over and over.
Yes, and when an AI's repetition ratio goes up, it means it's getting stuck in a loop. Not a good sign.
Got it. So we've got our sleepy AI guinea pig, and we're watching its perplexity and repetition to see if it's getting a good rest. Did they just, like, let it drift off on its own, or was there some kind of digital lullaby involved?
Well, they actually designed a multi-stage sleep cycle algorithm, you see.
A whole algorithm.
Yeah, it's like breaking down our own sleep into those different stages, REM sleep, deep sleep, and so on. And it all starts with what they call perplexity thresholding.
Perplexity thresholding, that sounds a bit like a sci-fi alarm clock. What is that exactly?
Well, think of it like the AI has a built-in confusion meter. If that perplexity starts creeping up past a certain point, it triggers a repair cycle.
Oh, I see. So it's like a signal telling the AI, hey, time to take a break and reset.
Exactly.
So the AI is like, whoa, too much thinking time for a nap. What happens during this little digital siesta?
This is where it gets really cool. They designed all these different interventions for those repair cycles, like stages of sleep, each with its own purpose.
Stages of sleep. Okay, walk me through it. What's the first step in this AI slumber party?
First, you've got what they call weight adjustment. You know how AI models are built on these complex networks of connections.
Yeah.
And each connection has a weight that basically determines how strong the signals are flowing through the network.
So kind of like how our brains have connections between neurons and they get stronger or weaker depending on how much we use them.
Exactly. A great analogy. And just like our brain connections, those weights can get a little out of whack in the AI too.
I can see that happening.
So during this weight adjustment phase, the AI makes these tiny little tweaks to the weights just to keep them from straying too far from what it learned initially.
Like a little digital tune-up, making sure everything's running smoothly.
Exactly. Then after the weights are adjusted, we move on to attention.
Attention.
Yeah, just like we need to focus our attention to learn. Effectively, AI has these mechanisms that decide which parts of the data are important for the task at hand.
So it's like telling the AI, hey, pay attention to this and don't get distracted by all the other stuff.
Precisely. Over time, those attention mechanisms can get a little skewed, and the AI starts focusing on the wrong things.
Right, right.
So this attention cleanup helps reset those mechanisms, make sure it stays on track.
Okay, so we've got the AI taking a break, adjusting its connections, cleaning up its focus. What's next on the sleep agenda?
Next up is memory consolidation, like when we sleep and our brains are sorting through memories, reinforcing the important ones and getting rid of others.
Oh, yeah, I've heard about that.
This stage is all about doing that for the AI, reinforcing the correct responses and purging any, like, bad memories, incorrect outputs that snuck in.
Ah, so it's like helping the AI remember what it learned correctly and forget the mistakes, cleaning out those digital cobwebs?
Exactly. And then just in case things get really messy, there's a final stage called emergency reset.
Emergency reset. Sounds intense. When would the AI need that?
Think of it as a safety net. If the AI gets so confused that nothing else is working, it can trigger this emergency reset.
Oh, okay.
It's like hitting the reboot button, but it still keeps the most essential knowledge.
So it's a last resort to prevent a total meltdown, but without having to start from scratch.
Right.
Clever, but with all these stages and interventions, I'm curious, how did they even know if this AI sleep therapy was actually working?
Well, remember those metrics we talked about, perplexity and repetition ratio?
Yeah.
They ran the AI through a bunch of tasks and watched what happened to those metrics over time, both with and without the sleep cycles.
Okay. And what did they find? Did this whole AI sleep thing actually make a difference?
Oh, it totally did. Without the sleep cycles, the AI's performance just tanked. I mean, its perplexity went through the roof.
So it was basically just spitting out gibberish.
Pretty much, yeah. And the repetition ratio, it just kept repeating the same stuff over and over like it was stuck.
Sounds like my brain after a long day.
Right. But then they introduced the sleep cycles and things changed dramatically. The decline of performance slowed way down, and get this, the AI was able to recover, like it bounced back near its baseline performance.
Wow, so those repair cycles really did their job, huh? It's amazing to think that just giving the AI a break can make such a difference.
It really is, and this has huge implications for the future of AI. I mean, think about it. AI systems that can function reliably for long periods without needing constant human intervention.
Yeah, like self-driving cars that can adapt to new traffic patterns on their own, or medical AI that can constantly learn from new data without losing its accuracy.
Exactly. We're talking about AI that can truly learn and adapt almost like a living organism.
It's incredible. This research is really pushing the boundaries of what we thought was possible.
Absolutely, and this is just the beginning. They're planning to test this on even more complex models, ones that combine text and visuals.
Whoa, AI that can understand language, interpret images, and repair itself all without human help.
Now that's exciting.
It really is. So let's recap for our listeners today. We started by talking about this big challenge in AI, those models that tend to degrade over time, losing accuracy, and producing nonsensical outputs.
Right, and the current fixes are like putting a Band-Aid on a broken bone. They don't really address the root cause.
Exactly. And that's where this research comes in by taking inspiration from how our brains recharge during sleep. They created an AI that can actually repair itself like hitting a refresh button.
And the results are super encouraging. This artificial sleep approach seems to really slow down that degradation and even helps the models recover near-peak performance.
So what does this all mean for you, our listener? Well, imagine a world where your smartphone gets smarter over time, learning from your habits without you needing to update it constantly, or AI doctors that can keep up with the latest medical breakthroughs and personalize your treatment in real time. That's the kind of future this research is pointing towards.
A future where AI is not just intelligent, but also resilient, adaptable, and capable of learning and growing on its own.
It's a future worth getting excited about, and if you want to explore this research further, you can find the open source code and publication on GitHub. Just search Richard Aragon Artificial Sleep.
Definitely check it out.
And that wraps up our deep dive today. We hope you found this exploration of AI sleep as fascinating as we did. Until next time, keep those brains buzzing, both biological and artificial.